Hello students, welcome to physics bouquet. We will read about radiation pressure for diffuse radiation in this video. इसका पहले हम नॉर्मल रेडिएशन के लिए पढ़ चुके हैं। तो डिफ्यूज रेडिएशन क्या होता है? जब कोई सरफेस के ऊपर फोटन्स सभी पॉसिबल डायरेक्शंस से जाकर गिरते हैं तो उसको डिफ्यूज रेडिएशन बोलते हैं। जब रेडिएशन नॉर्मल रेडिएशन होता है, राइट एंगल टू द सरफेस होता है, परपेंडिकुलर टू द सरफेस होता है, तो एक ही पर्टिकुलर डायरेक्शन में ऑल बीम ऑफ रेडिएशन, द बीम ऑफ रेडिएशन कम्स एंड इंसिडेंट. But here radiation comes to the surface, incidents on the surface from every possible direction. But one thing we should remember that it is isotropic. मतलब intensity of radiation from all directions are the same because it is dependent on temperature only. It doesn't depend on the nature of the surface or shape of the material like that. So this is diffuse radiation. For this diffuse radiation, let us consider a surface AB. AB is a surface. Actually, the surface is represented by a straight line, and this is a beam of radiation. A beam of radiation. Beam means it consists of so many rays. Beam of radiation falls on the surface AB with an angle theta to the normal. This is the normal to the surface AB. So the beam of radiation makes an angle theta with the normal. That means with the surface the angle is 90 minus theta. This is 90 minus theta. And AM, which is drawn, is the surface to which the beam of radiation is perpendicular. This is perpendicular. So AM is the surface to which beam of radiation is perpendicularly being incident, and AB is the surface to which the beam of radiation falls at an angle theta to the normal to the surface. Now we know that we generally denote U as the energy density. Energy density. Energy per unit volume. That is U. If we multiply U with C, velocity of photon, then U is energy per unit volume, and C is distance traveled per time. So this is distance traveled per time, and this is energy per volume. So if volume and distance traveled cancel, then we will get area here. Then it will be energy incident per unit area per unit time, because it is distance per time. It is distance per time, and U is energy per volume. If we cancel the distance traveled with volume, then we will obtain here area. Volume means area into the linear dimension, length. So this distance cancels. So energy per unit area per unit time. This UC gives us energy incident per unit area per unit time. Now suppose the surface AM to which beam is perpendicular, the area of the surface is suppose S, and that of AB is suppose S dash. तो S और S डैश के बीच में ये जो एंगल होगा, ये तो 90 माइनस थीटा, ये 90 है तो ये थीटा होगा. Hence we can express S in terms of S dash. This is, we have cos theta is equal to our area AM by area AB. So AM is S and AB is S dash. So this implies S is equal to S dash cos theta. Now energy incident per area per time is UCS. Then what will be the energy incident on this surface AM? Its area is S. This is energy incident per unit area. So unit area के लिए energy incident UC है, तो S area के लिए UC into S होगा. So energy incident is UCS. This is energy incident. Here energy means radiant energy on AM, surface AM. Now we can express S in terms of S dash cos theta. So using, in place of S, using this, we will obtain this is equal to UC S dash cos theta. This is energy incident on the surface AM. Now come to this surface. Whatever energy is incident on AM, it reaches surface AB. So energy incident on AB will be this much. Carefully listen. Energy incident on surface AM is UCS or UCS dash cos theta. The same energy is incident on the surface AB. So this is the energy incident on surface AB also. But what will be the energy incident per unit area on the surface S dash? Energy incident per unit area per unit time on surface AB. This is energy incident for the whole area. So per unit area we will divide S dash. So UC S dash cos theta divided by S dash. That will be UC cos theta. And on the surface AB per unit area per unit time. While reading normal radiation, we had rate of change of momentum. P is equal to what? This is P is equal to h nu by c. H nu is energy, so energy per c. So similarly, here energy incident per unit area per unit time is UC cos theta. Then what will be the momentum per unit area per unit time? Momentum of incident radiation per unit area per unit time will be energy incident divided by C. So C cancel out, that will be U cos theta. ये जो मोमेंटम if this momentum is observed fully, then the rate of change of momentum per unit time, matlab rate of change of momentum per area. But what is rate of change of momentum? That is force. Here force is radiation, force due to radiation. So momentum per time is force, and force per area is pressure. So when momentum is fully observed, we have rate of change of momentum, rate of change of momentum per unit area is equal to u cos theta, and this gives us pressure. That implies pressure is equal to u cos theta. So pressure due to radiation on this surface is u cos theta. The component of momentum in a direction perpendicular to the surface. Perpendicular to the surface. So to this surface, this is u cos theta. So perpendicular to the surface, it will be how much? See, this is 90 minus theta, and this is theta. So here u cos theta. So perpendicular to this, if this is angle theta and this is r, then we have this is r cos theta and this is r sin theta. So similarly here this is u cos theta. So normal to it, it will be u cos theta sin 90 minus theta. U cos theta into sin 90 minus theta. R cos theta is this component, R sin theta is this component. So here the component u cos theta का जो horizontal component होगा ये इस direction में हो. So it will be u cos theta sin 90 minus theta. But sin 90 minus theta is again cos theta. So cos theta into cos theta is cos square theta. So u cos square theta. So this is the component of momentum in a direction perpendicular. So this is a rate of change of momentum per unit area perpendicular to the surface. This is rate of change of momentum, the component of I have not written rate of change of momentum. The component of rate of change of momentum per area in a direction perpendicular to the surface is u cos theta into sin 90 minus theta. That is u cos square theta. And this is nothing but pressure. So our pressure on the surface is u cos square theta. But since the radiation is diffuse to the surface, the beams can travel in all possible directions like this, like this. That means it can make any angle. Theta can be Any angle between what? 0 to 90 degree. It can be any angle between 0 to 90 degree. So, see, this is surface AB. For easier explanation, let me drawing the surface as like this. Now, let me draw a perpendicular to this. Then radiation can move along this. Here this is theta, this is theta, or it can this direction, this direction. So this is another angle, right? So there will be different possible directions. If we, or it can be like this also. So we can get different possible directions due to diffuse radiation. Hence, what we will do, the pressure is U concentration is in every possible direction, though the intensity of radiation is same from all possible directions, that is isotropic. Hence, we can write P is equal to U average of cos square theta. But this average of cos square theta can be calculated as I will say henceforth. To calculate the average of cos square theta, let us consider a hemisphere. Let us consider a hemisphere. Suppose this is the axis of the hemisphere. Suppose this is point O. Let me consider a ring on the sphere. Suppose this is P, Q, R, S. Why I am considering, you will know just a little later. First consider this PQ. It is actually, imagine a hemisphere. We have taken this ring on this sphere. That means it is like this. Our front portion is looking, that side is like this. Suppose this is N. Now, join O with Q. Suppose this angle is theta. And join R with O. Suppose this is d theta. Student, you see, first concentrate on P. If I will complete this and suppose this, join this, then it will be a cone. So within this cone, the beam of radiation comes. Similarly, if I will consider this, then the beam of radiation comes within this cone. Therefore, I have taken theta and d theta. That means there are different possible directions. Therefore, suppose the direction in which a beam of rays comes with angle theta and another beam of rays comes with angle theta plus d theta. Now, suppose this is small r, ये जो हेमिस्फीयर का रेडियस सपोज स्मॉल आर, मतलब ये भी स्मॉल आर है. Then what will be this? This is theta, this is r, then it will be r sin theta. Sin theta is this by this, so this will be r sin theta. And one more thing, you consider this strip, this is d theta, then this arc will be how much? This is r. We know that theta is equal to arc divided by radius, L by r. So here arc is this much, then what will be r? L is equal to r into theta. Here in place of theta we have d theta, so this is the arc L, this is r, so d theta is equal to L by r, मतलब L is equal to r into d theta, मतलब this, ये जो width है ये r d theta है, right? जो ये जो कोन बना है इसका रेडियस है r sin थीटा, और ये जो स्ट्रिप है इसका विड्थ है r d थीटा, मतलब ये है r sin थीटा. समझ पाए? Now what will be the area of this strip? Cut it here and expand it. It will look like this. Cut it in the anywhere and expand it. This is r sin theta, मतलब ये सर्कल का सर्कमफेरेंस हुआ, तो सर्कमफेरेंस कितना हुआ? 2 पाई r. ये r की जगह r sin थीटा है, मतलब ये लेंथ हो गया 2 पाई r sin थीटा, और ये विड्थ है r d थीटा, तो ये r d थीटा होगा. तो इसका एरिया कितना हो जाएगा? एरिया ऑफ द रिंग 2 पाई r स्क्वायर sin थीटा d थीटा. समझ पाए? राइट. नाउ suppose n beams. A beam consists of many rays. N beams are spread over the hemisphere. N beams are spread over the hemisphere. हेमिस्फीयर का एरिया कितना है? टोटल स्फीयर का एरिया होता है 4 सरफेस एरिया 4 पाई आर स्क्वायर. ये हाफ ऑफ द स्फीयर है, सो 2 पाई आर स्क्वायर. सो 2 पाई आर स्क्वायर सरफेस के ऊपर n बीम्स स्प्रेड हुआ है. तो नंबर ऑफ बीम्स पर यूनिट एरिया ऑफ द हेमिस्फीयर, number of beams per unit area of the hemisphere. कितना हो? हेमिस्फीयर का एरिया 2 पाई आर स्क्वायर, n बीम्स, तो n डिवाइडेड बाय 2 pi r square. That means this is the number of beams per unit area of the hemisphere. Then what will be the number of beams associated with area of the ring? This is number of beams per unit area, then number of beams associated with the ring will be this into area of the ring. Then number of beams associated with, see, this is the total number of beams associated with the whole hemisphere, and area of the hemisphere is 2 pi r square. Then n by 2 pi r square gives number of beams per unit area. If we multiply this number of beams per unit area with area of the ring, then we will obtain number of beams associated with the ring. This is number of beams associated with the ring. So after cancellation of 2 pi r square, we obtain n sin theta d theta. This is number of beams associated with the ring. Then let it be denoted by dn. That means dn is the number of beams associated with the ring, and that dn is n sin theta d theta. So dn is the number of number of beams associated with the ring, and n is the number of beams associated with the hemisphere. So fraction of beams associated, fraction of beams of radiation, fraction of beams associated with the ring will be dn by n, and this dn by n will give us sin theta d theta. Now we had obtained P is equal to u cos square theta. This is for a single beam. P is u cos square theta. So for the fraction of beam associated with the ring, the P will be, suppose P dash is equal to dn by n into u cos square theta, and that will be sin theta d theta, dn by n के जगह sin theta d theta. So u cos square theta sin theta d theta. So this is for the fraction of the beam. Now if we consider the whole hemisphere, then what will be the pressure? Here this is the pressure for the range theta to theta plus d theta. Within this range, this is the pressure. Then for the whole hemisphere, a student can consider ring here, a student can consider ring here, a can consider ring here, another can consider ring here. So theta and theta will vary according to the consideration of the ring. But within what range theta will vary? From 0 to pi by 2. So the pressure, suppose I am denoting it by capital P. So P is equal to u cos square theta sin theta d theta. What is this P? This is the pressure for whole beams associated with the hemisphere itself, and it will vary from 0 to pi by 2. Now substitute cos theta is equal to x. Then this will be minus sin theta d theta is equal to dx. And when theta is 0, x is cos 0 means 1. When theta is pi by 2, x is cos pi by 2, matlab 0. So P will be 1 to 0, u को बाहर ले आते हैं, cos स्क्वायर थीटा की जगह x स्क्वायर एंड sin थीटा d थीटा की जगह माइनस dx. So that will be u. If we eliminate this negative sign, it will be 0 to 1, 0 to 1 x square dx, and we will obtain it to be x cube by 3 with integration range 0 to 1, and that is equal to u by 3. So pressure due to diffuse radiation is 1/3 of the energy density. This is all about diffuse radiation. So here the video completes. हम नेक्स्ट वीडियो में मिलेंगे. हैव ए गुड डे.